Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am dealing with thermodynamics, and in this lecture series this is lecture number 20. In this lecture I will explain you mathematical formulation of first law of thermodynamics. And for that let us take one system. Suppose A, this is initial state, and its internal energy say EA, and finally we reach here somewhere. This is B, the final state, and internal energy of this may be EB. Okay, so suppose system changes the state of A to B by absorbing quantity of heat Q. This heat is used up in two ways. First, to increase the internal energy of the system. Therefore, we can write delta E is the internal energy change, that is EB minus EA. Second, to do some work, external work, W, by the system on its surrounding. So thus we can say that heat absorbed by the system is equal to increase in its internal energy plus work done by the system. So mathematically we write heat absorbed is Q, change in internal energy is delta E, and W is the work. Or delta E is equal to Q minus W. This is the first equation of first law of thermodynamics. Okay. So it means that if the system loses heat to the surrounding, its internal energy decreases. Okay. Delta E would be negative, and work will be done by the system on surrounding and vice versa. Okay, so this is the case. Now we will see differential form. So according to differential form, for an infinitesimal process, equation 1 can be written as differential of, instead of delta we use differentiation, dE is equal to d cut q minus d cut w, or we write del q, the partial differential, minus del w. This is equation number 2. Okay, now we'll see two different cases. The first one, changing internal energy, delta U or delta E, is independent of the path taken. So since E is a state function, that means E does not depend on path. Its magnitude depends only on the state of a system, and the change in internal energy is independent of path by which it is accomplished. Therefore, exact differentiation of E would be dE. Let us consider this as this way. This is initial state A, final state B. Now, we go from A to B via this route, or maybe this route, or maybe this route. Okay, so here we can say that system changes from A to B state via three different paths. First, second and third. But delta E, which is final minus initial state, it remains constant or same. So this way internal energy change does not depend on path. Now second one, nature of del Q and del W. So Q and W are not state functions. Heat and work are not state functions. Remember, that means these are path dependents. So they are called path functions. Because first, the path by which the change is accomplished, and second, the previous history of the system. For example, we take one, we can explain this by a graph. Suppose this is A, initial state, this is final state B, and we go from A to B via this route, okay, where volume changes, and therefore this will be the work done. So this is work done for this system. Second possible state, or second possible way to reach from initial to final, this is initial and this is final, B. So we can go via this route and then this route. So again, in this case, this is the work done, W. Next one is this one, pressure versus volume. But here this is initial state and this is final state B. First of all, we go via this route and then we go this way. Okay, so here we can see that this much work is done, W. Okay, or it can be haphazard also, like this. A to B by various routes like this, then this much work is done. So here you can see in all cases the work done is different, okay, and therefore it shows that work is not a state function. So W is not a state function. Well, so it implies that W is not a state function, and we know that delta E is equal to Q minus W. Delta E is definite quantity, and W not a definite quantity. Therefore, we can say that Q cannot be a definite quantity. So, mathematically, infinitesimal changes in Q and W are not exact differentials, but are inexact differentials. And therefore, we write dE is equal to del Q minus del W. Okay, the quantities dW, del Q and del W adjust themselves. Sorry, del Q and del W adjust themselves. But delta E remain constant. Okay, so that's it in this lecture. Thank you so much.